Good morning, children. In the last two periods, we have learned about the properties of scalar product and also we solved some problems. Now we'll do some more problems and then we'll continue. Now, see, this problem is again very important. 4 points are given A, B, C, D. You must show that they are the vertices of a rhombus. Rhombus A, B, C, D. So, first always we take the points as A, B, C, D. A is OA, B is OB bar, C is OC bar, D is OD bar. Like this we'll take. Now you find the sides, AB side, BC, CD and DA. Find out all the four sides. Then you find the diagonal AC and also the diagonal BD. You already know that AB vector is position vector of terminal point minus position vector of initial point. So OB minus OA. So like that you subtract, you will get these values. Now AB vector, BC vector, CD, DA vectors we have. AC vector and also BD vector we have. Now you find the lengths. If all the four sides are equal, then it is a rhombus. So we'll find mod AB. So length of AB side is mod AB. Mod AB is, this is AB vector. So root of 2 square plus minus 3 whole square plus 6 square. So it is root of 4 plus 9 plus 36. So it is 49. That is 7. Similarly, when you take the length of the side BC, that is also equal to 4. Again, see, BC is minus 6 whole square. Minus 6 whole square means again 36. Minus 6 whole square plus again minus 2 whole square and then plus 3 square. So that is also equal to, again same sides, 2, 3 and 6. So you'll get 49. So that is 7. Similarly, CD, mod CD is also equal to root of 2 square, that is 4 plus 9 plus 36. So that is also equal to 7. And then mod of DA is equal to, again you will get the same thing, 6 square plus 2 square, that means again 36 plus 4 plus 9. So you will get again 7. So all sides are equal. Now you take the diagonal. So mod AC is root of minus 4 whole square, that means 16, plus minus 5 whole square, that is 25, plus 9 square plus 81. So it is 16 plus 25 plus 81. So it is root of 122. Now next you find the length of the diagonal BD, that is root of 8 square, 64 plus 1 plus 9. So that is root 74. You can see that the diagonals are not equal. So you will say, since mod AB is equal to mod BC is equal to mod CD is equal to mod DA. All sides are equal. And then the AC is not equal to BD. Mod AC is not equal to mod BD. That means the diagonals are not equal. So in a quadrilateral, if all sides are equal and diagonals are not equal, then it is a rhombus. Therefore, ABCD is a rhombus. Hence, it is proved. So, this problem is very important and you have similar problem in 3 dimensions also, coordinates in 1B paper also. Okay, now the second problem. See, in all these problems, we have the vertices as A, B, C. We should find A, B, B, C, C, A and all. So, we are directly writing the values. A is, you are given 3 points and you must show that they form the sides of a right angled triangle. And you must also find the other 2 angles. So what you do, first you take the points as A, B and C. So you find the vectors A, B, B, C and AC. All sides you find out. Then if the question is just to show that they form the sides of a right angle triangle, you can just find the lengths of the 3 sides and you can apply Pythagoras theorem. If the Pythagoras theorem is satisfied, you can or else you can show that the triangle is right angled, or else take the dot product of any two vectors. If the dot product is 0, then it is a right angled triangle. Okay, because we are in dot products chapter, we instead of using you can use Pythagoras theorem also, or you can use dot product. Suppose you are using Pythagoras theorem, you find out mod AB. Mod AB is root of 1 square. So minus 1 whole square plus minus 2 whole square plus minus 6 whole square. So what is it? 36, 41. So it is root of 41. Now mod BC. Mod BC is equal to root of, this is 4 plus 1 plus 1. That is root 6. And then mod AC. Mod AC is root of 1 plus 9 plus 25. So that is root 35. You can see when you are adding the squares of this, mod AC square plus mod BC square is equal to 35 plus 6. That is 41, which is equal to mod of AB square. Mod of AB square. So according to Pythagoras theorem, you can say that they form the sides of a right angle triangle. So where is the right angle? Right angle is at C, because in the right angle triangle, AB is the hypotenuse. According to this, AB is the hypotenuse. So C angle is the right angle. So according to Pythagoras theorem, angle C is equal to 90 degrees. So ABC form the sides of a ABC are the vertices of a right angle triangle. They are the vertices of a right angled triangle. So you can conclude like this. Or you can also see, take the dot product. Dot product is what? Just a product of these two, x, I coefficients, j coefficients, k coefficients, like that. So if you see, it is 2 into minus 1 is minus 2, and then this is plus 2 plus minus 6. This is not equal to 0. Now you take BC dot AC. BC dot AC. You can see that BC dot AC, or you can also use this property. BC dot AC is equal to 2 into 1, and then minus 1 into minus 3 plus minus 1 into minus 3 plus 1 into minus 5. 1 into minus 5. That is 2 plus 3 minus 5 is equal to 0. That means BC is perpendicular to AC. And so this C is the common point. So angle C is a right angle. C is equal to 90 degrees. So you can conclude. So A, B, C are the vertices of a right angle triangle. So you can use Pythagoras theorem, or you can use dot product. Okay, so now right angle triangle part is over. Now we must find the other angles. What are the other angles? Angles B and angle A. Now how to find the angle A? A is between AB and AC. A is the angle between AB and AC. A angle is the angle between AB and AC. So according to the formula, it is cos inverse of AB dot AC. AB dot AC by mod AB into mod AC. So this problem is very important. You please try this problem. Learn the method. So cos inverse of what is AB dot AC? We already found AB and also AC. So find AB dot AC. Minus 1 into 1. That is minus 1. And then minus 2 into minus 3 plus 6. Minus 2 into minus 3 is plus 6. And then minus 6 into 5. So otherwise you write like this. AB dot AC means minus 1 into 1. Minus 1 into 1 plus minus 2 into minus 3 plus minus 6 into minus 5 by what is the modulus of AB? Mod AB we already found now. So that is root 41 and mod AC is root 35. So it is equal to cos inverse of this is 3 to 6 minus 1. 6 minus 1 is 5. And then 6 5 is 30, 35. So it is 35 by root 41 into. So it is equal to 35 by root 41 into root 35. So again this root 35 you can write as 35 you can write as root 35 into root 35, and then you can cancel root 35 and write it as cos inverse of root of 35 by 41. So this is one angle. So angle A is equal to cos inverse of root 35 by 41. Now you find the other angle B. What is the other angle B? B is angle between BC and BA. B is equal to it is angle between BC and BA. Okay, now what is BC? BC is this. BA means it is minus of AB. So when AB is this, what is BA? BA will be minus of all this. So it is I plus 2J plus 6K. This is BA. Now angle between BC and BA is cos inverse of BC dot BA by mod BC into mod BA. So you can substitute all the values. So BC dot BA will be 2 minus 2 is 0. 2 minus 2 and then plus 6. So it is 6 by mod BC. Mod BC is root 6. And then mod BA or mod AB are same. So that is root 41. Again here you write 6 as root 6 into root 6 and cancel root 6. So you'll get cos inverse of root of 6 by 41. So this is another angle. This is another answer. So the other two angles are, so you will conclude and finally write as the other two angles. Therefore, the other angles are A is equal to cos inverse of root of 35 by 41 and B is equal to cos inverse of root of 6 by 41. So already angle C is 90 degrees. So we found all the three angles. Now the next problem is you are given A, B, C. These are three vectors. Find the vector R. Find the vector R such that these are the conditions given. R dot A is 9, R dot B is equal to 7, R dot C is equal to 6. So how to do such problems? Generally when we have to find some vector R, the variable vector R, we take that vector as xi plus yj plus zk. So we'll take let R is equal to, we'll write all the vectors A, B, C, given vectors we'll write, and then we'll write let R is equal to xi plus yj plus zk. Xi plus yj plus zk. Now A, B, C vectors you will write. Then you are given R dot A is equal to 9. R dot A is equal to 9. So that means this vector dot this vector is 9. That means xi plus yj plus zk dot of 2i plus 3j plus k. 2i plus 3j plus k. This is equal to 9. So what is the dot product? Multiply the I coefficients. So that means 2x plus again 3y plus 1 into z. Here it is 1. So 1 into z. So that is z is equal to 9. This is one equation. So like this way, if you take R dot B, again you are given R dot B as 7. So when you substitute here, you will get, as I said here, k is not there. So that means it is 0 into k, 1 into j, like that. So when you take R dot B, it is 4x plus 1 into y. So plus y, and 0 into z is 0. plus 0 is equal to 7. Is equal to 7. This is second equation. Next you are given r dot c is equal to 6. So r dot c. So x into 1. So x and then y into minus 3. So minus 3y plus minus 7 into z. So it is minus 7z is equal to 6. So these are the three equations which you have to solve. So how to solve these three equations and find x, y and z? After finding x, y, z, you can substitute. You will get the value of r, the required vector r. Find the vector r. So how to solve them? There is no particular method. You can just observe the equations and see how you can simplify. Now if you see these two equations 1 and 3, by just adding 3y gets cancelled. So we'll write like this. Equation 1 plus equation 3. So when you add 3y gets cancelled, it is 3x. 2x plus x, 3x, this gets cancelled. And then this is minus 6z is equal to 9 plus 6. That is 15. You can take 3 common and cancel. 3 into x minus 2z is equal to 15. So 3 gets cancelled. So it is x minus 2z is equal to 5. So this is equation 4. Now you got one equation containing x and z. So in the same way you can take these two equations also and find just cancel y. Multiply this by 3 and cancel. So equation 1 will take 1 is 2x plus 3y plus z is equal to 9. And then multiply this equation by 3 so that it gets cancelled. So second equation into 3. Multiply this by 3 so it becomes 12x plus 3y and this is 0 is equal to 3 times 21. So when you subtract, this gets cancelled. So it is minus 10x is equal to 9. So this is 12. Minus 12. So x is equal to minus 12 by minus 10. That is minus 6 by 5. X is minus 6 by 5. So here I forgot to take this z. So it is minus 10x plus z is equal to minus 12. So this is your fifth equation. Now you solve fourth and fifth equation. So solving 4 and 5. Solving 4 and 5, we get x. This is x minus 2z. So x minus 2z is equal to 5. So here also you try to get to 2. So you multiply this by 2. Then it becomes minus 20x plus 2z is equal to minus 24. So when you add these two, this 2z gets cancelled. So this is minus 19x. So you'll get minus 19x is equal to minus 19. So x is equal to 1. When x is 1, here when x is 1, so from fourth equation you will get 1 minus 2z is equal to 5. So z is equal to 5 minus 1 is 4. 4 by minus 2. That is minus 2. So x is equal to 1 and then z is equal to minus 2. Z is equal to minus 2. Now substitute the values of x and z in any one equation. Here we have this equation will substitute. So substituting in 2. Substituting in second equation you will get y is equal to 7 minus 4x. So that is 7 minus 4, that is 3. So you got x, y and z. So you substitute and you will get r is equal to, therefore r is equal to xi plus yj plus zk. That is r is equal to x is 1, so I, plus y is 3, so 3j, z is minus 2, so minus 2k. So like this you will get the answer. So solve the three equations and find. Okay. Now we'll go to the next topic. In the same dot products, we have two terms. Projection vector. What is meant by projection vector of A on B or B on A, and then now suppose that you have a vector A like this. This is a vector A. This is a vector A. And there is another vector B like this. This is another vector B. Then what is the projection of B on A? From B end points, you draw perpendiculars to A. So you will get a vector. This is, suppose that this is M and this is N. So this Mn vector is called as the projection vector of B on A. So Mn is given by the formula. It is called as the projection vector. It is called as the projection vector of B on A. So it is given by the formula. You just learn the formula. The proof is not necessary. So the projection vector of B on A is B dot A into A by mod A square. B on A is B dot A into A by mod A square. B on A. So B dot A. The rest of all are A. You just learn this expression. So the projection vector of B on A is this. Now if you draw a line like this, this vector, this is, suppose that this is P and this is Q. So this PQ vector is called as the projection vector of B perpendicular to A. It is called as the projection vector of B. Projection vector of B perpendicular to A. And it is given by the formula B minus B dot A into A by mod A square. B minus B dot A into A by mod A square. So this is also called as the projection vector of B on A or vector component of B on A. It is also called as vector component of B on A. So you can learn this formula. So the next topic is projection vectors. Projection vector of B on A. B on A. This is the formula. So if A is vector, this vector, suppose that AB is the vector A. The whole thing is vector A. Then this is vector B. Then draw perpendiculars. Then this length Mn is called as the projection vector. Mn vector is called as the projection vector of B on A or vector component of B on A, and it is given by the formula B dot A into A by mod A square. And then this vector is called as the projection vector of B perpendicular to A, in the direction of perpendicular to A. So that is given by the formula B minus B dot A into A by mod A square. Now suppose that it is A on B. Suppose that it is A on B. What is the projection vector of A on B? Projection vector of A on B. When it is A on B, the formula will be A becomes B, B becomes A. So A on B. So A dot B into B by mod B square. You can easily remember A on B. So A dot B. When it is B on A, it is B dot A into A by mod A square. When it is A on B, it is A dot B into B by mod B square. And similarly, this formula, projection vector of A perpendicular to B will be A minus A dot B into B by mod B square. Like that we write the formula. So learn these formulae, then we can do some problems. So it is also called as the orthogonal projection of B on A, vector component of B on A or projection vector of B on A, or it is also called as the orthogonal projection of B on A. These are the terms that are used in the questions. In some problems he mentions or find the orthogonal projection of B on A, then or vector component of B on A or projection vector of B on A. These are the terms used here. So you need not worry about this figure. You just learn the formula. The orthogonal projection of B on A, and then or projection vector or orthogonal projection vector of B perpendicular to A, like this. Learn the formula. Now if the question is find the projection of B on A, projection of B on A, projection of B on A means it is just the modulus of this B dot A into A by mod A square. So when you find the modulus of this, it becomes 1 mod A gets cancelled and you will get B dot A by mod A. So you can learn this as a separate formula, or else anyhow you will be finding the projection vector, no? So after getting that vector, you find its modulus, or you can use this formula. Now we'll do some problems based on this. So suppose that, so you can just write these formulae and then we can do 1 or 2 problems. First problem, suppose that A is equal to I minus J minus K, and then B is equal to 2I minus 3J plus K. Then find the projection vector of, find the projection vector of B on A, projection vector of B on A and its magnitude, So you know the formula, so you'll just substitute. So first find B on A, so it is B dot A into A by mod A square. So you will find B dot A. What is B dot A? In the solution you will find B dot A. B dot A is 2 into 1, 2, minus 3 into minus 1, 3, and then 1 into minus 1, minus 1. So 5 minus 1, that is 4. So you will just write, so the projection vector of B on A is equal to B dot A into A by mod A square. B dot A into A by mod A square. So what is it? B dot A we got as 4 into A vector will write. So it is I minus J minus K by mod A square. What is the modulus of this? Root of 1 square plus minus 1 whole square plus minus 1 whole square, whole thing whole square, mod A square. So root will go. So it is 4 into I minus J minus K by root 3 whole square, that is 3. So this is your answer. So the projection vector of B on A is this. Now you must find its magnitude. So its magnitude is modulus of 4 into I minus J minus K by 3. 4 by 3 is a number, so you can write outside the modulus and you can just write the modulus of I minus J minus K, that is 1 plus root 3. So 4 by 3 into root 3. Modulus of this is root 3. So it is 4 by root 3. So its magnitude is 4 by root 3. So like this we do. Just learn the formula and do. Now take down this homework. A, B are non-collinear vectors. Find the angle between A and B. So what you do is, you are given this vector, this equation. So as I said, whenever you have modulus, you will square on both sides. So mod A plus B whole square is equal to mod A minus B whole square. So write mod A square plus mod B square plus 2A dot B. Here mod A square plus mod B square minus 2A dot B. Then what happens? Mod A square mod B square gets cancelled and you will get 4A dot B is equal to 0. So that means A dot B is 0. When is A dot B 0? When they are perpendicular. So the angle between A and B is 90 degrees. So like that you will conclude. Now you can take down the next problem, homework. Another problem. PQRS are 4 points. PQRS are points with position vectors. I minus K and then minus I plus 2J and then 2I minus 3K and then 3I minus 2J minus K respectively. That means P is this point OP, OQ, OR, OS. Then find the component of RS on PQ. You can try this problem. You will get the answer as minus 4 by 3. Answer is minus 4 by 3. So the method is, you will find RS vector. RS is nothing but OS minus OR. So that is your A. And then PQ vector, OQ minus OB. That is B vector. So component of A on B is A dot B into B by mod B square. A on B. A dot B into B by mod B square. This is the vector component, but he said only component. So I'll find the modulus of it. So what is the modulus of it? When you find the component of A on B will be, one mod B will get cancelled. So you will be finding this value. So A dot B by mod B. So that is your value minus 4 by 3. You can try this problem. We'll continue in the next period.